This video is a good follow-up after you've watched the one on electron configurations. And once you understand electron configurations, determining valence electrons is actually fairly simple. So, valence electrons are just another way of saying outer shell electrons. So these are pretty much just valence electrons. If we consider the electron configuration of nitrogen, it's 1s2, 2s2, 2p2. And my outer shell is going to be my largest energy level. Or, really, what I'm talking about here is these numbers in my electron configuration, right? And the largest one will refer to my largest energy level. So in the case of nitrogen, I'm talking about the electrons that are in the second shell. Well, that includes all of these in the 2s and all of these in the 2p subshells. And so that means my valence electrons for nitrogen are 4. How many valence electrons are present in a bromine atom? Well, if we do the electron configuration for bromine, it would take a while. So let's do the noble gas shortcut. We've got argon, and then bromine is 1, 2, 3, 4, 4s2, 3d10, 4p5. What's our valence shell? Well, it's our outermost shell, and when I look at this, I see that the biggest shell number that I have is 4. This is a 3, and so it's not in my outermost shell, and so I'm not going to count it as part of my valence electrons. What I will count are these guys and these guys. And so we'll say that bromine has 7 valence electrons. There's a shortcut that we can get from looking at the periodic table. If you think about, say for instance, the halogens, since we just did bromine, and we said that bromine had 7 valence electrons. If we did the electron configuration for fluorine, it would be 1s2, 2s2, 2p5. Oh, check that out. I've got my valence shell is shell number 2, and it has 2 plus 5 electrons, which means, hey, 7 valence electrons. In fact, all of the halogens have 7 valence electrons. And in fact, I can count that because I see fluorine is here. I can count 1, 2, 3, 4, 5, 6, 7 to get to fluorine. So pretty much all I'm doing there is counting the boxes that were in the same row as fluorine. Now we know in our example with bromine that we leave out the transition metals because those are not in the same shell. So for instance, if I wanted to figure out the number of valence electrons of tellurium, I would count 1, 2, skip these guys because they're in a lower shell number, 3, 4, 5, 6. 6 valence electrons. Guess what? Everybody in this column, that is actually everybody, has 6 valence electrons. So you can start to deduct, oh, these guys have 5, and these guys have 4, and these guys have 3, and look, that's the same as these numbers that you see in Roman numerals for the group. And over here, it works as well. I've got 1 valence electron for that column and 2 valence electrons for that column. It doesn't work for the transition metals, obviously, because they have that lower shell number.